So my name is Elaine. I work at Sphere, and welcome to my talk about building voice-first iOS apps. So first of all, I wanted to give you 3 reasons why you should care about voice in your app. First reason is the most evident one, is hands-free actions. There are situations where you should not, where you cannot or you should not be manipulating your smartphone. So, of course, situations such as driving or cooking are completely evident for hands-free actions. Then voice is an interface that allows people that have certain disabilities, such as visual impairments, cognitive disabilities, or dexterity problems, to use technology and have access to information and to services that people that don't have those disabilities can. So it's really nice to have an interface that is accessible to those people. And the third one is basically preparing ourselves to the next generation. I'll give you 5 seconds to finish this, reading this tweet. It's basically the newest generations are going to expect for objects surrounding them to answer to them when you talk to them. So we just have to prepare ourselves to this new generation. So what do you need to do? There are 4 features that you can integrate inside your app to implement voice interactions. The first one is the hot word or wake word detection, then speech-to-text speech recognition, the machine learning part with the NLP and NLU, and text-to-speech and voice synthesis. And this is what it looks like inside a system. So here we have a user saying a wake word with the voice command. The system has the wake word detection, so it would start listening, and it would transform what has said, what the user said with the voice command. It would transform the audio to a text or to a string. This string can then be used inside a machine learning process that will basically transform this string into intents, entities, basically parameters that we as developers can use in order to calculate our answer, do our business logic, and then give, calculate the textual answer that will be also a string. And then through the final block there, the text-to-speech will transform this text, this string, in audio that will be given back to the user. So this is the most important diagram in this presentation. Please learn it very well. I'm going to be presenting that a lot of times. So before looking into how you can actually implement those solutions, I'd like to talk to you a little bit about the history of voice interactions on iOS. What I wanted to show you with this diagram right here is that voice efforts have been integrated in iOS since the very early versions. So you can see that features such as voiceover, speech features, speech accessibility features, and Siri were integrated very early. And then you can see developer tools that were integrated on later versions. We can see that the efforts around that area around voice and around machine learning in general are very important. So let's take a look on what you as a developer can do in order to integrate those solutions. So I'll be focusing first on the first-party solutions, so the solutions provided by Apple. And the first one is using diverse APIs and frameworks that we saw with Hervé on the talk just before. So this is our famous diagram, and this is the solutions that you can use in order to integrate in your project. So you can use Siri Shortcuts to do the wake word detection. You can use the speech framework for the speech-to-text, the natural language framework for the NLP part, and the AVSpeechSynthesizer for the text-to-speech. So let's take a little closer look into those solutions. So Siri Shortcuts, it's a kind of limiting using Siri Shortcuts only for the wake word detection, only for the start listening part. It's a lot more than that. I really encourage you to take a look into what you can do with Siri Shortcuts. So basically, you can take advantage of Siri to perform actions directly on your app inside of Siri, or you can also ask Siri to open your app to a specific screen, so really powerful. And you can integrate it by declaring an intent definition. There's something that you have to declare on Xcode. And then we talk about donate. You can also do something that is called donating the intent, which is basically telling the OS how your user is basically using your app with the user activity. And so Siri can learn your user's behavior and be proactive and suggest your shortcuts to your users. And as Hervé was also talking about, you can add phrases to Siri with the shortcut button, the Add to Siri feature. And what is really interesting too is that your app is now accessible from a bunch of places inside iOS, such as the Spotlight search, the lock screen, and the Siri watch face. And on iOS 13, Siri Shortcuts have been upgraded to a dedicated app on iOS 12. It used to be on the Settings app where you had your shortcuts. Now every iOS 13 user has a dedicated app dedicated to shortcuts. And also on the right, you can see the Add to Siri screen has also been updated. So the speech framework. Speech framework is pretty straightforward. It basically allows you to transform live or pre-recorded audio to text. You have a 1 minute limit because battery and because network. And on iOS 13, there's this new property that Hervé also talked about, is the support on device recognition that allows offline speech recognition, which is really nice. Then natural language framework, we saw a lot of examples on Hervé talk. There's a lot of features that are available, very powerful framework. You can do tokenization, log identification, identifying linguistic tags, doing text similarity with synonyms, with text embedding. And then, really interesting too, we saw at the previous talk, integrating custom models to use with this framework right here, and those models can be trained inside your map, can be created and trained on your Mac using CreateML. So really powerful. And then the speech synthesizer, again, pretty straightforward. There's very few lines of codes that you need to integrate in order to have your app say something out loud to the user. So here you can see a minimal code that is needed to have your app say hello world. Even though this is a very simple, easy to integrate framework, it is very powerful. There are a lot of customizations and features that are available, so I really encourage you to look into that. To illustrate, I have here an example where you can customize the pronunciation of your words. So here we are using, if you see on the bottom, we are using the British voice, but we are forcing basically an American pronunciation to say the word tomato instead of tomato, that is said with a British voice. So again, only an example of things that you can do. You can do a bunch of more stuff with the speech synthesizer. So this was using those frameworks on those APIs. You can also focus on using the intent extension provided by SiriKit. So again, our favorite diagram of how things work. And this is what it looks like when you're using the intent extension. So if you integrate with the intent extension, you are delegating everything. All the blocks that are on the diagram are going to be managed directly by SiriKit. Everything that you have to do is to implement this extension. So yeah, it's very nice, very easy to integrate, to voice enable your app using SiriKit. But the downside, maybe all of you know, is that your app has to be doing something that is provided by the Siri Domains. So there's not a lot of use cases, but maybe yours has one of those features. And one novelty is the media domain that was just announced this year. So there are solutions that are provided by Apple, but there are also some third-party solutions that I was interested into looking at. So this is what I found out. For the hot word and wake word detection, you have some solutions. All of those solutions, they work offline. This kind of model can work really well offline. And then for the machine learning part, there are a bunch of solutions that I looked into. And you can see there are different aspects into them. Some of them work offline. Some of them require internet connection. And for those who are requiring internet internet connection, which are basically the model is running on a server. The server can be either hosted by you, or you can rely on the server of the provider. The biggest advantage of using those kind of third-party solutions is that most of them, they are cross-platform. So you are maybe integrating those solutions inside of your app, iOS app, but thanks to the cross-platform aspect, you can reuse this project to integrate with other platforms such as Facebook Messenger, Android app, and others. So here you have examples of other platforms that are supported by those solutions. So to wrap up, I wanted to give you some examples of things that you could see in real life. Again, our favorite diagram. And here are some examples of some architectures that you could imagine. So on the first one, we are basically using all of iOS features for all of the blocks, but for the machine learning part, we are using the SNP solution. I only want to show you that you can mix and match also those solutions to tailor to your needs. And on the bottom example, we're using Pico Voice, a third-party solution to do the wake word detection, the speech framework for the speech recognition, and Open Ears for the machine learning part. And then you can see that I am not doing the text-to-speech part. Maybe you can imagine some use cases where it's better for the user to only have a visual answer. And what I wanted to showcase with those two examples too is that by using a Siri, you can have since Siri can be triggered anywhere on the OS, your app can be closed, and when you are using a third-party solution such as Pico Voice and others, your app has to be opened first to integrate with this feature. So two more examples. The first, the top one, is using all of iOS frameworks and features to do all the stuffs, but I skipped the machine learning part. We can also, there's a completely valid example too, to do very basic commands, and maybe your system only needs some keyword detection and something like that, and you only need the speech-to-text and the text-to-speech, or even not, and everything can be managed directly on your app. On the other side, you can only do, on the bottom, you can, there's an example here that I'm showing where you can only do the machine learning part by taking directly the input that was typed by the user and give back a visual answer to your user. And as Javier was saying, a really nice way to get into with machine learning is using this to maybe do an advanced search feature inside of your app. And just to a reminder, when you're using Siri Kit with Siri extensions, you are delegating everything, so completely valid use case too, if your app falls into one of the Siri domains. So yes, that's all for me. Thanks very much.
Thank you. Thank you. So we'll ask Hervé to join us, and Elaine, if you can join us right here. In my company, we have a joke.
Sorry?
We usually say that when it's in a PowerPoint, it's AI, and when it's on Python, it's machine learning. Yeah, thank you. It's really interesting to see like your vision of AI is like, okay, there are a lot of things that are happening. Usually we're asked to do amazing things, and leveraging existing iOS blocks to do that is really interesting and really pragmatic. So I like this way of seeing. And every new release, we see new intents on Siri, we see new features in the machine learning frameworks. Which new features do you think could come from the research world, and or which breaks would you like to see?
Well, I guess for iOS, the next necessary feature will be on-device translation, I think. Yes, I had the opportunity to ask people like Paul Hudson when it would come, and he's also very convinced that it would arrive sooner or later, maybe in 1 year or 2 years. they can't do differently. We need this.
Yeah. And so we spoke much about iOS, but actually one issue we might have is that when I was talking about mobile apps, iOS just like the best 50% of the market, but of course on the other hand, since you have lots of stuff which is on device, it's proprietary API. We have only that on iOS. How can we achieve ISO functional apps on the other side of the moon?
Very good question. If you're relying on first-party APIs, I think it's impossible because, well, it's just going to be working differently. Mm-hmm. So maybe this is why if you have, well, your app has an iOS app and you have your Android app, maybe you should look into maybe some third-party solutions that can basically do what you want, have the same functionality, exactly the same functionality for those platforms.
And is TensorFlow like a viable option today?
Have you tried? No? You don't like? Okay. I know about it, I haven't tried, but yes, I was going to say yes, but maybe you say no, okay.
And let's say you train a model that is available on iOS and Android. Could you be able to train it like the same way on both platforms and reuse some part of the job? If you
using first-party solutions or third-party? Yeah. There's a very good question. I think I was even on Coco Head's meetup where someone, I think it was you actually, who asked the question if you could use the TensorFlow model on a Core ML to reuse exactly the same model that could be used on Android. And I think there was no clear answer to that. Or it was really, really difficult. I don't remember. Yes, but it would be really nice.
I'm not interviewed, so I mean,
maybe it wasn't you. It was someone else.
I'm not sure. I guess there is actually no easy answer to that. But
yes, there's no.
Anyway, it could be done until a certain extent. But anyway, actually, what else we can do to improve the UX experience, in your opinion?
Yes, it's an important thing. This year at DubDub, there was a great session about how to create nice machine learning experience. It was interesting because it was led by UX designers. Speaking of machine learning, it happens not that often. And the main idea was that what you have to care about is trust. You don't have to do a lot of hidden stuff under the hood, and you have to show where suggested values come from. If you have metrics like some likelihood, some percentage, you have to provide them to the user, saying, well, you can do this, but I'm not sure it's the right solution. Right? And also take into account the feedback that users can bring to you if they have a possibility to say that, no, sorry, this was not right.
Yeah, one or 2 years ago, we had a talk from Matthew Hauser from a virtual company, and he was also explaining how they handled machine learning to detect parts of the car based on photos, and how they changed the UI to instead of just proposing one solution, they would propose a few, and this would improve a lot the use of the system, and like relying on the fact that you are not sure of the result, then you need to adapt the UX.
And on voice is especially hard because you have errors all the time, because all the tools are here, but they're not perfect. They're not perfect, and the recognition may not work. You may not have a reliable connection. So managing errors, as you say, voice designers, they always say in voice, in conversations, there are no errors. If you don't understand something that I'm saying, you're going to ask for some detail, or can you please re-explain? And you have to take all of this into account when you're designing those kind of interactions.
And how do you, how would you start to go further? I mean, to learn more, and actually, do we need to know more, or just we stop there and we are just stay a boring developer?
Yes. Well, I was a bit concerned because I have a medical certificate from my doctor saying that I cannot do Python, so I couldn't go very far.
Can I have the address of your doctor?
I will give it to you. So, but clearly, this is the first thing that you will want to do. And don't do like me. I tried, of course, but I have
I saw you saw many cats photos where you were doing Python.
Yes, you can see. But I have 3 installs of Python of my macOS. I know I have issues that nobody on Stack Overflow ever had. So you should install it in a Docker. So the second thing you have to learn is Docker. And then there are great tools like to recreate, for example, which can help you create, develop models easily. Well, that's what they're saying.
Okay. Shall we move on?
Yes.
Okay. Thank you very much for your both talks.
Thanks.
Okay.